Hey guys, it's Leia. Today we will learn how to solve integrals using partial fraction decomposition. When we are given an integral with p of x over q of x with respect to x, we check to see if the degree of p of x is less than the degree of q of x. And if so, then we have two cases. Case 1 is when p of x is the derivative of q of x. In this case, we would just use u substitution to solve the integral. Case 2 is when p of x is not the derivative of q of x. In this case, we use partial fraction decomposition. So we are going to be focusing on case 2 because we already know how to solve case 1. First, let's go over how to make a partial fraction. A partial fraction is when we take a complicated fraction and break it down into smaller ones added together. Let's see an example to refresh our memories. We have 2x plus 3 over 5x squared plus 16x plus 3. We know 5x squared plus 16x plus 3 has factors of 5x plus 1 and x plus 3. So we'll use each of the two factors as a denominator. We have a over 5x plus 1 plus b over x plus 3. Next we have to find out what a and b are. So we set the numerators equal to each other, and don't forget to multiply the numerator by the opposite denominator so they have the same denominator. We'll multiply out the function on the right side, and then we'll reorganize it and pull out the common factors. From this, we can set up a system of equations where 2 equals a plus 5b because they have a common factor of x, and 3 equals 3a plus b because they're all constants. And then you'll solve for a and b and get the answer and substitute that back into the fraction. Let's see our first example. We have the integral of 2x plus 6 over x squared minus 5x plus 6 with respect to x. We see that the numerator has a smaller degree than the denominator and that the numerator is not the derivative of the denominator, so we will set the integrand equal to a partial fraction. The factors of the denominator are x minus 2 and x minus 3. So we'll have a over x minus 2 plus b over x minus 3 as the partial fractions. And now we need to find what a and b are. So we set the numerators equal to each other, and then we multiply out the right side. Next, we'll reorganize, and now we can create a system of equations and solve it. From solving it, we'll get a equals negative 10 and b equals 12. So we substitute these values back into the fraction, and now we can substitute the partial fractions in for the integrand. We then use the sum rule and separate the integral into two. Next, we use the natural log identity, which we can see here. We get our answer, negative 10 ln of x minus 2 plus 12 ln of x minus 3 plus c. Last example, we have the integral of x squared plus 2x minus 1 over x cubed minus x with respect to x. We want to turn this fraction into partial fractions. So we know that the factors of x cubed minus x are x, x minus 1, and x plus 1. So this fraction is equal to a over x plus b over x minus 1 plus c over x plus 1. Next, we must find the values of a, b, and c. So we set the numerators equal to each other. We multiply out the right side and reorganize it. Now we create a system of equations to find a, b, and c, and we'll eventually get a equals 1, b equals 1, and c equals negative 1. So we can substitute that back in for a, b, and c, and now we can substitute this partial fraction into the integrand. We use the sum rule and the natural log integral identity, and we'll eventually get our answer, ln of x plus ln of x minus 1 minus ln of x plus 1. Solving integrals using partial fraction decomposition isn't too hard, but it requires a lot of practice to refresh your memory on how to do it. So for more help, visit www.simbolab.com and click on the Practice tab.